Hello all, welcome to the session. So this is Jemilin Benita, Assistant Professor from the Department of Costume Design and Fashion. So today in this session we will be discussing in detail about non-ovens. So before starting non-ovens, first let me explain what are non-ovens. So as we all know, there is a general structure or a general flow chart for fabric manufacturing techniques. So there are different fabric manufacturing techniques which includes weaving, knitting and non-ovens. So what is the speciality about non-ovens is the general flow is fiber to yarn and yarn to fabric. But whereas in non-oven we do not have the intermediate yarn, whereas the fiber will be directly converted into fabric form. So let us see a definition for non-oven. Non-woven fabric is a structure produced by bonding or interlocking of fibers, or it can be both by bonding and interlocking, accomplished by mechanical, chemical, thermal and solvent means. So initially the fiber is formed and then it is bonded using mechanical, chemical or thermal. We will be discussing in detail about all the process. So there are three main steps involved in non-woven formation. So the first is the formation of web, bonding of web and the finishing of web. So in this video we will be discussing in detail about web formation. So we can classify web formation into two, staple fiber system and the polymer system. So in staple fiber system it is further classified into dry laid and wet laid. In polymer system it is further classified into spun bond and melt blown. So steps in web formation, there are three steps involved in web formation: fiber preparation, carding and web stacking. So in fiber preparation we have fiber opening, cleaning and blending, and in carding we get output as web, and that web from carding is gone to the next process called as web stacking. So in this session we will be dealing in detail with web stacking process, that is the output from the carding is web and that web will undergo a process called as stacking. And in stacking we have two types, parallel lay and cross lay. So stacking is nothing but arrangement of web one over the other. So first we will move on to the dry laid process. So this is one of the web formation process. We can just have a quick overview of the dry laid process. So initially we have the raw material. It may be a natural fiber, man-made fiber or any inorganic fibers. Then we go through the preparation process as we discussed, opening of the loose material and blending. Then we go to the formation, that is carding process. Then we have web bonding. It may be mechanical, thermal or chemical bonding. Then we move on to the processing, that is the finishing or dyeing or printing or coating. Then finally we get the output, non-ovens. So as I already discussed, what is web stacking? So it is just the arrangement of fibers or the web one over the other. So what are the objectives? The major objectives of the web stacking process are to increase the web mass, to increase the web width, to determine the web strength and to improve the end product qualities. So these are the four main objectives of the web stacking process. Moving on to the parallel lay process. So in dry laid process we have parallel lay and cross lay. So in parallel lay process we are having several revolving flat cards. So a conveyor lattice will run below all the cards for the entire length. So the web which comes out from the carding machine is laid over the conveyor lattice. So by this way successive cards are laid over one over the other. So by this we will get a bat. So like BATT, bat is nothing but when the web is laid one over the other we term it as bat. So the conveyor carries the laid down bat to the bonding process. So let me show you the image so that you get a clear understanding. So as you can see, these rollers indicate the carding rollers. So the output from the carding, that is web, is passed on to the conveyor lattice. So the below represents a conveyor lattice. So the web from the card is passed on to the conveyor lattice. As you can see, the successive cards, it will also pass the web over one over the other, and the output from the parallel laying process is BAT, that is BATT, which is nothing but the arrangement of web one over the other. So there are two terms which we have to know here is machine direction and cross direction. So what is machine direction is the direction in which the web is produced is called the machine direction, and the other direction, the opposite direction, is called as a cross direction. So if you take the parallel lay process, here the webs are arranged in the machine direction. As you can see, it is in the longitudinal direction. Machine direction is nothing but the feed direction. So here the webs are arranged in the feed direction. So here you will have higher strength in the machine direction compared to the cross direction. So in the machine direction, the strength may vary up to 8 to 10 times greater than the cross direction, which is also one of the disadvantages of the parallel lay process. Moving on to the next, it is cross-lay process. As the word itself suggests, here the arrangement is going to be in the cross direction when compared to the parallel lay. So this is most common bat formation process. So let me say why it is common. We'll see it in detail. So first, what is the process is, you will have a lapper at the end of the card, which helps in the arrangement of the web in the cross direction. So in this cross-lay process, you have two types, camelback laying and horizontal laying. So what is the objective of this cross-lay process is, as you can see, first you will get bat with a higher weight per unit area. So in both parallel lay and cross lay, you will get a bat with a higher weight. So because of course the webs are arranged one over the other, so obviously the weight will be higher. Next, the main advantage of the cross lay is the width of the bat will be higher than the card web. So because since it is cross laid, you can even adjust the width, but in parallel lay, the width is restricted to the card width. Next, you can obtain preferentially orientation of fibers in the transverse direction. In parallel lay, you will have fibers only in the machine direction, whereas here you will have both in machine direction and cross direction. So this is a picture of camelback laying. So let us see the process in detail. So in camelback laying, first the web will come out of the card and it is carried to a pivot point by means of a conveyor, and you also have another conveyor system through web is brought down, and you have a cross conveyor through which the arrangement of web happens in the cross direction. Next you have another type of cross lay which is called as horizontal laying. So this also operates at the same as camelback laying. Let me show you the diagram. So this is the picture of horizontal laying. As you can see, the web from the card will move through several conveyor lattices, and through which you will get the arrangement of web in a zigzag manner. So this is a picture of horizontal laying. Next, let me give you the comparison between cross laying and parallel laying. So in parallel laying, the width is restricted to the card width. So like from the web, card web width will be more or less equal to the width of the parallel laid web. In cross laying, you can have wide widths of non-woven. You can increase the width, and you have greater uniformity in strength in cross laying. So as I already discussed, since the fibers are oriented both in cross direction and machine direction in cross laying, you will have preferentially almost similar strength. You can see the ratio here 1:1.3. CD to MD is nothing but cross direction to machine direction strength. Whereas in parallel laying, MD to CD ratio is very higher. It is up to 8 to 10 times greater. In cross laying, investment is higher as the machinery costs are higher, whereas in parallel laying, less investment can be done. So in this video, we have discussed about the web formation technique of dry laid. So in dry laid, we have two techniques, parallel lay and cross lay. In cross lay, again it is of two types, camelback laying and horizontal laying. So in the next video, we will continue with the polymer web formation system. Thank you.